Jurassic wasn't simply the age of dinosaurs. It was the greatest age of giants Earth had ever seen. Yet behind every giant was a daily struggle. Every meal carried a risk. Every journey could become a fight for survival. Every day was another test in a world that never stopped changing. This is the story of how giants survived. Before we begin, subscribe to the channel and join us as we continue exploring the incredible world of prehistory. Most of us grew up watching the incredible bite force of predators that lived much later. But if you had stepped onto the floodplains of North America around 150 million years ago, you would have met a very different kind of hunter. A herd of Brachiosaurus moved slowly across the open plain, feeding peacefully among scattered conifers. Hidden in the tall ferns, something watched without making a sound. It did not rush. Every movement of the herd was carefully studied. Every possible escape route had already been considered. Here, patience often meant the difference between eating and going hungry. Then the opportunity appeared. One young Brachiosaurus drifted only a few steps away from the protection of the herd. Instantly, the predator burst from cover. Powerful legs carried it across the plain in seconds. For a brief moment, the hunt looked certain. But the adults reacted just as quickly. The mother stepped directly between the predator and her offspring, while several other giants closed ranks around them. Long tails swept through the air as legs thicker than tree trunks pounded against the ground. One careless step beneath those enormous feet could turn a hunter into a victim. The predator slowed, hesitated, then quietly turned away. That decision was not a failure. It was exactly what had allowed Allosaurus to dominate the late Jurassic for millions of years. An adult measured around 30 to 36 feet long and weighed roughly 2 to 3 tons. It was impressive, but far smaller than the Tyrannosaurus rex that would appear nearly 90 million years later. Its bite was also much weaker. Yet none of that prevented it from becoming the apex predator of its world. Instead of relying on raw power, Allosaurus hunted with precision. Its lightweight skull and powerful neck muscles allowed it to deliver repeated downward strikes, a hunting technique many paleontologists call the hatchet bite. Rather than crushing prey with a single bite, it opened deep wounds, stepped back, waited, and struck again when the opportunity returned. The rest of its body followed the same strategy. Strong hind legs provided explosive bursts of speed, while muscular forelimbs, armed with 3 sharp claws, helped control struggling prey. Every part of its anatomy favored timing, agility, and accuracy over overwhelming strength. Its greatest weapon, however, may have been patience. At the famous Cleveland Lloyd Dinosaur Quarry in Utah, scientists uncovered the remains of dozens of Allosaurus together. Some researchers believe they gathered around the same carcasses. Others suggest they occasionally hunted or fed in loose groups when facing prey far too large for a single predator. If that idea is correct, it helps explain how an animal weighing only a few tons could challenge giants many times its own size. That is why many paleontologists compare Allosaurus not to a tiger, but to a lion. Not because it was the strongest predator of the Jurassic, but because it knew exactly when to attack and when to walk away. The giant prehistoric creature that forced even Allosaurus to retreat was Brachiosaurus. As the herd continued across the floodplain, the danger behind them seemed to disappear. The young stayed close to the adults, unaware that it had nearly become a predator's next meal. For these giants, every day followed the same rhythm: eat, keep moving, protect the herd. Brachiosaurus was among the tallest animals ever to walk the earth. A fully grown adult could stand nearly 40 to 43 feet tall and weigh 35 to 50 tons. Even its name reflected its unusual body plan. Brachiosaurus means arm lizard, a reference to its front legs, which were longer than its hind legs. That unique posture lifted its shoulders high above its hips, allowing its neck to reach vegetation that few other herbivores could access. While many plant eaters competed for shrubs and low-growing ferns, Brachiosaurus fed high above the forest floor. Its long neck slowly swept through the upper canopy, stripping leaves from branches that remained untouched by almost every other dinosaur. By feeding where few rivals could reach it, avoided much of the competition for food. That advantage came with an enormous cost. An animal weighing up to 50 tons needed to consume hundreds of pounds of vegetation every day simply to sustain its massive body. Nearly every waking hour was spent feeding. Finding enough food was not a daily task. It was a constant necessity. Protecting the next generation was just as important. The youngest animals rarely wandered far from the center of the herd. Adults surrounded them on every side, creating a moving wall of gigantic bodies. Brachiosaurus had no horns, no armor, and no heavy tail club. It relied on something even more effective: its extraordinary size. A single leg was thicker than many fully grown dinosaurs, and every step carried several tons of weight. That was exactly why Allosaurus had abandoned its attack. A predator built for speed and precision understood that one mistake beneath those towering feet could end the hunt instantly. Sometimes the smartest decision was simply to wait for another opportunity. As if nothing had happened, the herd continued feeding. The young Brachiosaurus stretched toward another cluster of fresh leaves, while the adults calmly watched the landscape around them. For now, the giants had won. But hunger never disappeared for long. Somewhere beyond the trees, the lion of the Jurassic was already searching for another chance, and before long, it would find a very different herd. For several more days, Allosaurus continued searching. Each failed hunt drained more energy. Every mile it traveled meant burning precious calories with no guarantee of success. Hunger was becoming a constant companion. Then, at the edge of a broad river valley, it found another opportunity. A herd of Diplodocus stretched across the open floodplain, feeding quietly among low vegetation. Unlike the towering Brachiosaurus that browsed high above the forest, these giants carried their remarkably long necks almost level with the ground as they moved slowly through the landscape. From the tip of the snout to the end of the tail, a fully grown Diplodocus could reach nearly 90 to 100 feet in length, making it one of the longest dinosaurs ever discovered. More than 100 vertebrae gave its neck and tail extraordinary flexibility, allowing such an enormous body to move with surprising grace. Yet despite growing to almost unimaginable size, its brain weighed only about 3.5 ounces, roughly 100 grams, no larger than a tennis ball. At first glance, these prehistoric animals didn't seem dangerous at all. But to the Allosaurus, they represented an opportunity. Among the adults were several juveniles. One of them had gradually drifted away from the herd, stopping to feed on a patch of low-growing vegetation. This time, Allosaurus didn't hesitate. It burst from the trees, charging straight toward the young Diplodocus. The startled juvenile bolted across the floodplain, but before the predator could close the distance, the adults reacted. Several enormous Diplodocus quickly converged around the youngster, forming a living barrier, while their extraordinarily long tails swept through the open space behind them. Any predator that ventured too close risked being struck by a tail capable of delivering tremendous force. Faced with a wall of giants and the constant threat of those powerful tails, Allosaurus slowed, hesitated, and finally backed away. Once again, Diplodocus demonstrated that simple but effective group behavior could be enough to frustrate even one of the Jurassic's most skilled predators. Many paleontologists believe this was likely why Allosaurus usually targeted juveniles, older individuals, or injured animals whenever the opportunity arose, avoiding the enormous risk of confronting healthy adults head-on. However, during the Jurassic period, even the most skilled predators weren't always successful. Days passed, and Allosaurus still had nothing to show for its efforts. Every failed hunt meant another day without enough food. Hunger was beginning to outweigh caution. This time, its attention settled on a lone Stegosaurus feeding at the edge of a forest clearing. Compared with the towering sauropods, Stegosaurus looked like a far easier target. It measured about 30 feet long and weighed several tons, far smaller than either Brachiosaurus or Diplodocus. Two rows of enormous bony plates rose along its back, giving it one of the most recognizable silhouettes in Earth's history. Even today, paleontologists continue debating the exact purpose of those plates. They may have helped regulate body temperature, served as display structures, or perhaps performed both roles at different times. From a distance, however, Allosaurus paid little attention to the armor of scales. Hunger left little room for caution. Once again, it cautiously closed the distance, hoping this attempt would finally bring a meal. Moving slowly through the trees, the predator circled behind its prey, searching for an opening. But Stegosaurus reacted almost immediately. Instead of running, it calmly pivoted its body, keeping its tail pointed directly toward the approaching hunter. Every time Allosaurus shifted to one side, Stegosaurus turned with it. Neither animal rushed. Both waited for the other to make the first mistake. Then, without warning, the tail exploded sideways. The Allosaurus paid the price for its impatience. Once again, it failed. Even more surprising, Stegosaurus achieved all of this with a brain no larger than a walnut. Its small brain has often become the subject of jokes, but survival does not always depend on intelligence alone. Stegosaurus relied on instinct, perfect positioning, and one extraordinarily effective weapon. As long as it could keep its tail facing the danger, even one of the Jurassic's greatest predators had to think twice. No movement was wasted. Fossils tell us this confrontation was more than imagination. Several Allosaurus skeletons preserve injuries that closely match the size and shape of Stegosaurus tail spikes. The injuries reveal that not every attack ended in the predator's favor. In the Jurassic, the predator did not always control the outcome. Sometimes it was the prey that forced the hunter to retreat. While the forests above were ruled by giants, another world thrived beneath the waves. At first glance, it might have looked strangely familiar. Something streamlined cut effortlessly through the water, chasing a school of fish with astonishing speed. It resembled a modern dolphin, yet it had appeared nearly 200 million years before dolphins ever existed. This was Ichthyosaurus. Its body had been shaped by evolution for one purpose: speed. A powerful crescent-shaped tail drove it through the ocean with remarkable efficiency, while its streamlined body reduced drag with every movement. Unlike many marine reptiles, Ichthyosaurus rarely needed to rely on ambush. It could simply outrun much of its prey. This prehistoric creature's enormous eyes were just as extraordinary. Some ichthyosaurs possessed the largest eyes ever known in any vertebrate, measuring more than 10 inches across. Reinforced by a ring of bony plates, these massive eyes allowed them to gather as much light as possible, helping them hunt in the dim waters far below the sunlit surface, where many other predators struggled to see. One female was carrying her unborn offspring as she continued searching for fish. Every successful hunt helped sustain not only her own body, but the new life growing inside her. Day after day, she continued swimming through the Jurassic seas, unaware that her final journey had already begun. Then, during labor, everything stopped. She died while giving birth. More than 180 million years later, paleontologists uncovered one of the most extraordinary fossils ever discovered. Inside the skeleton of the mother, the unborn baby was still preserved. Another young was already emerging from the birth canal, frozen forever in the final moments of delivery. It was as though time itself had paused in that instant, preserving one of the most intimate moments ever recorded in prehistoric life. The fossil revealed something rarely seen in the ancient world. Even the fastest hunters, even animals perfectly adapted to life in the ocean, still faced moments they could not overcome. Survival was never guaranteed. Even in the safest waters, life always came with a cost. But speed was only one way to survive beneath the Jurassic seas. Other predators relied on an entirely different strategy. They didn't chase their prey across the ocean. They waited and struck with surprising precision. While Ichthyosaurus chased its prey through open water, another predator had mastered the opposite strategy. It understood that sometimes the less you moved, the greater your chance of success. Suspended almost motionless beneath the surface drifted Plesiosaurus. Its body was unlike anything alive today. 4 powerful flippers slowly carried it through the water, not with side-to-side movements like a fish, but with graceful strokes that resembled flying beneath the sea. Even after more than a century of research, scientists continued to describe its swimming style as one of the most unusual forms of underwater movement ever evolved. Its long neck immediately caught the eye. In some species, the neck accounted for nearly half of the animal's total body length, supporting a surprisingly small head armed with slender, interlocking teeth designed to grip slippery prey. Instead, the neck was likely used for slow, careful positioning before a quick, precise strike. A school of fish drifted overhead, completely unaware that anything was waiting below. Plesiosaurus barely moved. Its flippers made only the smallest corrections as it blended into the dim blue water. It allowed the fish to swim closer and closer until they entered striking distance. It was a completely different solution to the same challenge. Ichthyosaurus succeeded by outrunning its prey. Plesiosaurus succeeded by letting its prey come to it. The Jurassic seas were filled with hunters, yet no single strategy dominated them all. Evolution continuously experimented, producing prehistoric creatures that solved the same challenge in remarkably different ways. On land and beneath the sea, the rules were the same. Survival did not belong to the strongest, the fastest, or the largest alone. It belonged to the animals that found the strategy that worked best in their own world. As millions of years passed, the Jurassic became far more than a world filled with enormous animals. It became one of the greatest evolutionary experiments Earth had ever witnessed. No species could afford to remain the same for long. Every improvement in one animal created a new challenge for another. As prey grew larger, predators had to become smarter. Allosaurus refined its hunting techniques because brute strength alone was no longer enough. Every successful hunt demanded patience, precision, and perfect timing. At the same time, giant herbivores continued changing as well. Brachiosaurus reached incredible heights, allowing it to feed where few other animals could compete. Diplodocus stretched its body to extraordinary lengths while turning its powerful tail into an effective defense. Stegosaurus invested less in speed and more in protection, carrying one of the most formidable defensive weapons of the Jurassic. Even beneath the oceans, the same pattern unfolded. Ichthyosaurus evolved into one of the fastest marine hunters of its time, while Plesiosaurus mastered the art of patience, waiting motionless before striking with astonishing precision. No animal was ever perfect. Every adaptation solved one problem while creating another. Every advantage lasted only until another species evolved a better response. Survival was never permanent. Every victory was temporary. That endless cycle transformed the Jurassic into perhaps the greatest evolutionary arms race the planet had ever known. And together, those changes created a world unlike anything before or since. Vast conifer forests stretched beyond the horizon. Herds of gigantic sauropods moved slowly across ancient floodplains. It was never just one extraordinary species that defined the Jurassic. It was the way they lived together, hunted together, defended themselves, competed, and forced one another to keep evolving. That is why the Jurassic is remembered not simply as the age of dinosaurs. It is remembered as Earth's greatest age of giant prehistoric creatures. Today, all that remains are fossilized bones buried beneath layers of ancient rock. But every skeleton tells the story of a real animal that once fought to survive in one of the most spectacular ecosystems our planet has ever created.
Imagine standing in the heart of the Sahara Desert today. As far as the eye can see, there is only endless golden sand and a vast empty sky. It is one of the driest places on our planet. Harsh, silent, and seemingly lifeless. But just beneath the surface, only a few meters to tens of meters down, lies a completely different world. Satellite radar images and careful archaeological work have revealed ancient river channels and the shores of long-vanished lakes. They have also revealed stone tools left behind by people who once lived here. It is as if an entire lost landscape has been carefully preserved under the sand. How is it possible that one of the driest places on Earth could hide such a rich and vibrant past? There was a time when fresh water filled vast lakes, when lush savanna grasslands stretched for hundreds of miles, when elephants and hippos roamed freely, and when ancient communities built their lives along the water's edge. Recent studies have given us a much clearer picture of this green Sahara. Deep sediment records show that these humid green periods did not happen just once. They returned roughly 20 times over the past 800,000 years. Each cycle was driven mainly by the slow wobble of Earth's axis, a natural motion known as precession, part of the larger Milankovitch cycles. This understanding has been strengthened by new climate modeling and sediment research published in Nature Communications in 2023. Even more striking, scientists have discovered that the final transition to desert around 5,500 years ago was not sudden. Instead, it was foreshadowed by repeated short-term climate fluctuations. Periods of severe drought lasting several decades would alternate with wetter times recurring roughly every century or so. These dramatic fluctuations were carefully documented in sediment cores from the Chu-Bahir Basin. Today, we are not simply retelling an old story. We are looking at new scientific findings from recent years that help us understand this place in a different way. Beneath the sand is not emptiness. It is a mysterious world waiting to be discovered. These deserts have not always been as silent as they seem. Around 14,500 years ago, the Sahara began to change. Rains that had been absent for thousands of years slowly returned. Over time, the barren desert transformed into a vast green landscape. Scientists call this remarkable era the African Humid Period. What we see today as endless sand was once a living savanna. Tall grasses stretched across the plains. Rivers flowed for hundreds of miles. Enormous lakes dotted the landscape. Life followed the water. Herds of elephants roamed the open grasslands. Hippos and crocodiles thrived in the rivers and lakes. Prehistoric human communities settled along the coast, hunting in this unimaginably fertile land. For a long time, scientists believed this green Sahara happened only once. But newer research reveals a far more astonishing truth. Over the past 800,000 years, these wet periods have returned roughly 20 times, following a natural rhythm about once every 21,000 years. These cycles were driven by the slow wobble of Earth's axis, known as precession. And here is something even more remarkable. Not every green period was the same. During colder periods when massive ice sheets covered much of the northern hemisphere, the monsoon weakened and the Sahara never became as green as it once was. The end of the most recent green period around 5,500 years ago did not happen suddenly. Scientists have found evidence of repeated short-term swings between wet and very dry conditions. Long droughts lasting decades would interrupt the rains only for wetter periods to briefly return. The proof of this lost world is still visible today, scattered across what is now one of the harshest deserts on Earth. During the African Humid Period, Mega Lake Chad spread across a vast area of about 350,000 to 400,000 square kilometers. That is close to the size of the Caspian Sea and nearly as large as the state of California. In some places, the water was more than 100 meters deep. At times, it likely flowed south into ancient river systems and may have reached the Atlantic Ocean. Even now, the signs are clear. Ancient shorelines, old beaches, and wave-cut cliffs are still visible across the desert. Some of these features lie hundreds of kilometers from the small Lake Chad we see today. Fossils of Nile crocodiles, hippos, and elephants are often found in the sand. Many are buried just a few meters below the surface. These animals once lived in a land rich with water and plant life. Archaeologists have also found stone tools, grinding stones, arrowheads, and ancient sites. These were left by people who lived, hunted, and fished here. Most of these remains date back to between 10,000 and 5,500 years ago. Together, these clues show a very different Sahara. Not empty, not barren. The Sahara was once a land filled with water, wildlife, and human life. This was not a myth, it was real. And in the long story of our planet, it disappeared. But the most vivid evidence of this lost world does not come from bones or ancient lake beds. It comes from the hands and eyes of the people who once lived there. High on the remote sandstone cliffs of Tassili Niger in southern Algeria lies one of the greatest open-air galleries of prehistoric art anywhere on Earth. More than 15,000 paintings and engravings cover these canyon walls, spread across a protected area larger than many American states. These artworks were created over more than 6,000 years, beginning around 6000 BC and continuing into the early centuries of our era. They form a remarkable visual record of a changing world. UNESCO recognizes the site as a priceless treasure that captures the relationship between humans and their environment during the Green Sahara. The earliest ones, known as the Round Head period, show mysterious human figures, with rounded heads often appearing to float or dance in graceful ceremonies. As the centuries passed and the climate remained wet, the art shifted to the Pastoral period. Here we see families herding cattle, milking cows, and living beside large herds. In the final Camel period, the images change again as the land slowly dried and camels became common. Many scenes are strikingly alive. You can see people swimming in lakes and hunting elephants and giraffes with bows and spears. They are also shown dancing in rituals and gathering around what appear to be boats on wide rivers. These vivid pictures capture the moment when humans moved from a life of hunting and gathering to one of herding and settled communities along the shrinking waters. Far to the south in Niger, at a windswept site called Gobero, archaeologists uncovered something equally extraordinary. On an ancient lakeshore dune, they found the oldest known cemetery in the Sahara, containing nearly 200 burials. This place holds the remains of two distinct groups who lived thousands of years apart. The earlier Kiphian people around 10,000 years ago were tall and powerfully built hunters and fishers. Centuries later, after a long dry gap, the smaller and more lightly built Tenarian people returned. They kept cattle, made beautiful pottery, and adorned themselves with necklaces of eggshell and ivory. Recent studies of ancient human remains from the broader Saharan region, including new genetic research published in recent years, suggest something important. These early communities contributed to the genetic makeup of later African populations. Some of their descendants appear to have carried helpful adaptations for surviving in increasingly dry environments. When you stand before these rock paintings or walk along the ancient shores of Goboro, the experience becomes real. You are not simply looking at old pictures or bones, you are looking at real mothers and fathers, children and grandparents. They laughed, loved, hunted, danced, and adapted as their green world slowly disappeared. They left us a quiet but powerful message written in paint stone and buried bones. The Sahara was once their home, a place full of life and possibility, and they thrived here long before the desert claimed the land once more. Beneath the Sahara, there are discoveries that seem almost impossible at first glance. Not just traces of rivers or human life, but entire environments that do not belong in a desert. One of the most striking examples lies in Egypt in a place known as Wadi al-Hitan, or the Valley of the Whales. Here, scattered across the sand, are the fossilized remains of ancient whales that yesed nearly 40 million years ago. Among them was Basilosaurus, a long, large, prehistoric creature that once dominated the warm seas of the ancient world. Some of these fossils still retain small hind limbs, suggesting their ancestors once walked on land before returning to the ocean. Today, this landscape is dry and silent, but long ago it was covered by a shallow sea connected to a much larger ocean system. These remains are not just unusual. They are clear evidence that the Sahara was once underwater long before it became a green savanna, and long before it turned into the desert we see today. But the Sahara still holds more surprises. Just a few hundred kilometers away, an enormous geological marvel rises from the sands. The Risha structure, or Eye of the Sahara, is a massive circular formation visible even from space. Its concentric rings of rock tell a story of ancient volcanic activity and erosion preserved for millions of years. The structure may not have held life like Wadi al-Hitan, but it is a monument to Earth's dynamic forces, a silent record of the planet's shifting crust and climate over geological time. Another mystery appears in the form of glass. About 29 million years ago, an immense burst of energy melted vast areas of sand in a very short time, forming what scientists now call Libyan desert glass. Across parts of the desert, pale yellow fragments lie scattered across the surface. At first glance, they look like ordinary stones, but they are not. They are natural glass created when sand was exposed to extreme heat. Recent studies reveal that this glass also shows signs of intense pressure and rapid cooling evidence, consistent with a high-energy cosmic event. Many scientists believe it was caused by a fast-moving object entering Earth's atmosphere or striking nearby. Yet, despite decades of research, no confirmed impact crater has been found, and the exact cause remains debated. What is certain is the scale of the event. For a brief moment, the desert reached temperatures high enough to melt sand into liquid, leaving behind a field of glass that persists to this day. Humans thrived only in the upper layers of the Sahara. They lived along rivers and lakes that existed thousands of years ago. Beneath millions of years of sand and rock lies an even older world, vast reservoirs of fossil water hidden deep underground in the Nubian sandstone aquifer system. This is not a river or a lake. It is a vast underground reservoir filled with water, one of the largest freshwater reserves on Earth. This is ancient water, often called fossil water, formed under very different climate conditions. Modern hydrological studies as recent as 2024 confirm that much of this water is non-renewable under today's climate. Some of it fell as rain thousands of years ago. Some may be far older. Modern engineering has made it possible to bring this water to the surface, supporting cities and agriculture in some of the driest regions on Earth. But this resource is limited. Once it is used, it cannot be quickly replaced. It is water from a different world, now being consumed in a desert that no longer creates it. And yet, the story doesn't end there. In recent years, new technology has revealed yet another hidden layer. Using satellite imaging and ground-penetrating radar, researchers have discovered the outlines of ancient settlements buried beneath the sand. These are linked to the Garamantes, a civilization that once thrived in what is now southern Libya. Hundreds of structures, including fortified towns and long trade routes, have been identified. This was not a scattered population. It was a connected and organized society supported by careful water management. Over time, as water sources declined, their system became harder to maintain. Eventually, the cities were abandoned, and the desert slowly covered everything. Taken together, these discoveries reshape how we understand the Sahara. This was once an ocean where cosmic forces left their mark, where ancient seas supported giant creatures, where water still lies hidden underground, and where human stories remain preserved beneath the surface, waiting to be uncovered. The Sahara is more than sand. It is a layered archive of Earth's history, silently waiting for us to read its story. Now we begin to understand what truly shaped this lost world. The Sahara did not change randomly. It changed because of a slow movement of the Earth itself. This movement is called precession, a gentle wobble in the planet's axis. It happens over thousands of years, and it changes how sunlight reaches different parts of the Earth. To understand this, imagine summer in northern Africa becoming slightly stronger. When that happens, the land heats up more than usual. This is the monsoon. When the sunlight is stronger, the monsoon becomes stronger. And when the monsoon moves farther north, it brings rain deep into the Sahara. With enough rain, everything changes. Dry ground turns into grassland. Rivers begin to form and connect. Lakes grow larger and deeper. Trees spread across the land, animals follow the water. Herds of antelope move across the plains. Elephants travel between rivers. Hippos rest in shallow lakes where today there is only sand. The Sahara becomes a living landscape. But this system is fragile. When the Earth's wobble shifts again, summer sunlight becomes weaker. The monsoon weakens. Less moist air reaches the region. Rainfall begins to drop. Rivers shrink. Trees begin to disappear. At the same time, another process makes the situation worse. As plants vanish, the soil is left exposed. Wind begins to lift fine dust into the air. This dust reflects sunlight and cools the land. The cooler surface weakens the monsoon even further. Scientists call this dust feedback. It helps push the land from green to desert. Studies published in 2024 show that this pattern was a warning sign. The system was becoming unstable before it finally settled into a dry state. This idea matters today. Scientists now watch for similar patterns in modern climates. Repeating droughts and unstable rainfall may signal deeper changes ahead. Some climate models even suggest the Sahara could receive more rain again by the end of this century. But this does not mean it will fully return to the green world of the past. The conditions that created that world were very specific. As we reach the end of this journey, one idea stands out clearly. The Sahara is not empty. These vast lakes were once home to early human communities. They adapted to the shifting environment and left their mark on a landscape that was always changing. What we see today is not a living ecosystem, but the remains of one carefully sealed by time. Deep underground, massive reserves of ancient water still exist, stored for thousands to millions of years. Scientists often describe it as an underground ocean, not because it is truly an ocean, but because of its immense scale and importance. The Sahara also acts as a natural archive. Its layers record shifts in climate, the rise and fall of ecosystems, and the movement of human populations. It reminds us that Earth is always changing. No environment is permanent.